Alright, so if this thing is working, hello YouTube. Uh, I am an IB student. Um, yeah, I'm going to teach you chemistry. Anyways, let's get on with it. Um, firstly, I'm going to start with topic 1, and I suppose we'll go all the way to 10, but for now, this video is just going to cover some of the basic terminology that will be used throughout the course, sort of what it means, and sort of go over the basics first. So we start here. Chemistry is the study of matter and its composition, and how it's what its composition is, how it's made up, how atoms bond, so on and so forth. And matter is defined as anything that has mass. Um, I'm not going to go through this stuff in italics here. Um, I'll put a Google Drive link to these notes here that I'm currently using, and you can read it at your own leisure. Um, I hope so. I'll put it in the description. I don't know if I actually will or not, but if I do, then there you go. Otherwise, sure, you could find them somewhere because I did make them publicly available at some point. Whatever, we'll get through that later. So, we could divide matter into two things. We can divide it into something that doesn't have constant composition, so a mixture, or we could divide it into a pure substance, which does have constant composition. Um, what do I mean by a constant or inconstant composition? If I show you on my second screen here, so if I show you on the second screen here, something, we're going to say the left has constant composition, whereas the right one doesn't. So this is a constant composition. Um, so as you can see here, it's only made up of black dots, whereas not constant composition, say, has a red dot in addition to some of those black dots. So with constant composition, we can break it down into one small repeating unit, whereas with non-constant composition, there are multiple smallest repeating units, more or less, is sort of what I mean. Now, if we go back, a substance is something with constant composition, as I just said. We can divide substances into, furthermore, into elements and compounds. Within the compounds, we could talk about molecular compounds, so things that are composed of molecules, i.e., water, methane, so on, or um, complex lattice structures, which are called macromolecules, so sodium chloride or silicon dioxide. And what I mean by that is, if we go again, here, let me just, I need to erase everything. Here, I just quickly, if I undo everything there on paint, I'll go back to my paint window. So by sort of what I mean by that is we have small repeating units like so. Just imagine that's filled there. So as you can see here, we have a nice uniform crystal lattice. Just imagine that's filled there. I kind of suck with drawings, so you're gonna have to forgive me here because I'm using MS Paint, but I suppose this is what you get for a passion project, I guess. So atoms are what we call the smallest building block of matter, and according to the Dalton model, all atoms of a particular element are the same, and a molecule is two or more atoms which are held together by covalent bonds. Molecular formula is just a symbol showing how many atoms of each type there are in a molecule. So H2 has 2 hydrogen atoms, S8 has 8 sulfur atoms bonded together, diatomic oxygen has 2 oxygens bonded together, CO2 is made up of carbon, which is bonded to 2 oxygen atoms, and you sort of get the point here. Whereas an element is just a substance that contains only one type of atom. So we use a molecular formula to more or less show the elemental composition of a molecule and how many atoms of each element there are in any given molecule. So, for example, in one molecule of glucose, which is this one here, C6H12O6, we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. And then a compound um, is made is a type of substance made by chemically combining two or more elements in a fixed ratio. So here are some examples. Whereas an element is just a type of substance containing one type of atom. An empirical formula gives the simplest ratio of numbers between atoms of each element present in a compound. So the empirical formula is just the simplest ratio, like a formula written down as the simplest ratio. So for example, the molecules N2O4 and NO2 have both the empirical formula NO2 because the 2 in N2O4 divides through. It's a common factor. And then now we go on to talk about states of matter. Substances commonly exist at solid, liquid, or gas. So with a solid, everything is densely packed, whereas a liquid, it's a little bit less packed, and then a gas is just sort of all over the place. And we can describe sort of, and generally speaking, the more, I suppose, the less packing there is, the less packing there is, the more kinetic energy that substance has as a whole. And the way we can measure this is by using temperature, which is defined as the average kinetic energy of a particle within the substance. For gas, we have what we call the kinetic theory of gases, which we'll go on to talk about a little bit later, but it's essentially made up of these 5 points. When we go on to talk about gas laws and stuff, we will we'll describe this in more detail, but for now, all we need to know is that a gas is a state of matter for which the volume and shape of the material varies. Solid is where they're held constant, and a liquid is somewhere in the middle where the fixed volume but the varying shape. And here are the different changes of states of matter. Freezing and melting, I hope you're familiar with, as with these two. Deposition is gas to solid, and sublimation is solid to gas. Those two you may not have heard of, however, there you go. Most of these definitions are quite obvious. I'm not going to go over them. However, again, it's just more or less what I set up there. And you should be really familiar with freezing, melting, condensing, and boiling, because those are stuff you really see every day. But for the sake of going them over, melting is solid to liquid, freezing is liquid to solid, gas to liquid is condensation, and liquid to gas is boiling or evaporation. Evaporation, it just happens at room temperature. That's the only difference there. A chemical change is a change of substances into other substances through reorganizing of the atoms or rearrangement of the valence electrons, if you want to get technical there. And we could describe a physical change as a change in the form of a substance, but not in its chemical composition. So a physical change is just changing the substance up. So for example, a physical change would be ripping paper, mixing salt and water, because it still has the properties of the stuff you put in it, whereas a chemical change, it results in something with different properties entirely. Now that we talked about substances, we now go on to talk about mixtures. We can have homogeneous mixtures or solutions, or heterogeneous mixtures. You're only really going to ever be working with solutions, so I won't go too much into detail with it, but for homogeneous mixtures, it's just evenly mixed. So what do I mean by evenly mixed? Here, well, again, I will grab a sheet of paper, also known as paint, and I'll sort of draw that out for you. So here, if we had like, I would say that's evenly mixed, whereas unevenly mixed is like, oh damn it, like that. Like you can clearly see here, this is evenly mixed, this is unevenly mixed. So that's sort of what I mean by that. Now just open a new paint window so I have it ready for the next time. Heterogeneous mixtures are just mixtures that contain substances that are unevenly mixed. Homogeneous mixtures, here's some examples. If we have something of two metals, it's called an alloy, so that's something you need to know. For heterogeneous mixtures, it's slightly more interesting here. If we have particles of a solid suspended in a liquid, we call it a suspension. If it's liquid, droplets of a liquid in another, we call it an emulsion. A foam is bubbles of one substance trapped in a solid, so gas and salt trapped in another one. And a gel is a solid where it's a liquid, but there are solid strands restricting the movement of said liquid. So Jello and hair gel are examples. Styrofoam bread is a gas solid foam. A gas liquid foam is a soap sud. An emulsion is like Italian salad dressing, with olive oil and water. They don't mix. So when you mix it, you have the droplets of oil suspended in the water. Uh, Fog is liquid and gas. I'm not going to go through all these. This is really unimportant. It's not really interesting or something we care about. It's more just to set the framework for what you're going to learn over the next 2 years. Yeah, 2 years. So I just went over that. So just to quickly recap, we have an element is a pure substance with atoms of one type, which is the simplest type of substance, which has distinct properties. A compound is similar, except that it has different properties than the atoms you combine, the constituent atoms. In addition, there are two or more types of atoms. Uh, a mixture is something with two or more substances. Um, you can combine it in any ratio, whereas a compound is a fixed ratio. You make it by physically combining things, and the properties seem to average out the properties of the components. I have four multiple choice questions here. Pause the video now if you want to do them, and I'll give you 10 seconds, and then I will highlight the answers, I guess. Alright, so now that you're back, we're going to quickly do which statement is false. A sample of an element consists of atoms of one type. That's not true. Compounds can and elements can never consist of molecules. Uh, no, hang on, let's go back. A sample of an element contains atoms of the same type. That's true. We know that's true. B here, compounds can and elements can never consist of molecules. This is probably not true. Let's go over some of the other options before we mark it down. A sample of compounds consists of atoms of two or more types. That's true. Compounds can and elements cannot be decomposed. We also know that's true, so therefore the answer is B. For number 2, the answer is it's a D, I think. It's D. For the third one, it would be and by purity, I forgot to discuss this. Purity just means of one type. It's the same thing throughout. This one is the false one. And then the last one is B. Because N408 is a different molecule entirely. They all have the same empirical formula NO2. There's a 2-to-1 ratio, yep. And each molecule contains that one. N408 is not a possible molecular formula. It's another possible, I suppose, I wouldn't say empirical formula, but the ratio is also correct, I suppose, in that one. But it's not true, because a molecular formula has the number of elements in it, like in the actual, it has the number of elements in each molecule, so, of that thing. So that should cover it. Thank you very much for watching. I'm not even going to bother with the whole don't forget to like and subscribe thing, because